sorry. So there is a best choice of a denominator. You really could use any denominator you want. But the best choice is the least common denominator. It's the best choice in that you'll have the least amount of simplifying in the end to do. So if you add and subtract and then you have to write your answer, you have to simplify it, that is. With the least common denominator, you'll have the least amount of simplifying at the end. Okay? It's kind of like with rational numbers, there's a best choice of a denominator. Same thing here. Yeah. Someone happened. Oh. Okay, it's okay. Someone said that their connection isn't working great, so they have to leave. Again, that's fine if you tell me that, but you don't have to. It's okay. I understand things happen. So technology can be our friends, but it's not always. So it's okay though. All right. Anyway, all right. So from here, I was going to say, okay. But how do we find the LCD? Well, this is actually what it is. It's the polynomial of smallest degree that has each of the denominators as a factor. It's the polynomial of smallest degree that has each individual denominator as a factor. Okay, that's what it is. How do you find it? Well, the process is there, and I know this process looks confusing. It's really not as bad as it looks. I mean, it does take factoring, of course, as you can see. Essentially, you factor each polynomial, and you raise, and then what you do is you list the factors, you find each factor's biggest exponent, and you raise each factor to its biggest exponent and multiply. And we're going to do some examples of that now. It's not as bad as it appears. It's actually kind of fun. Let's do it together. So let's say we have this pair. We're not actually going to add or subtract. All I want to do here is find the LCD. And here it's a little bit easier because the denominators are already factored. Okay, all right, that's cool. So what do we do? Well, x minus 1, that's an irreducible factor. When I say irreducible, I just mean you can't factor it down any further. That's all we mean. That's all we mean. You can't break it down any further. Irreducible. Okay. So x minus 1, excuse me, let's see. I list x actually, we can list first. You can see the only exponent of it is 1. So we're going to list 1 as its largest exponent. So if the factor is all alone, its exponent is the largest one. We have x minus 1, right? So that's listed. But there's 2, but this is also in the other denominator. You know, the exponent here, remember, if an exponent is not listed, it's understood to be 1. So here we have a 1. Here we have a 2. So its largest exponent is 2. And just like with x, we do have an x plus 2. Not over here, but over here. And its only exponent is 1. You know, there's no x plus 2 over here. So we just write x plus 2 and then a 1. And then the LCD is x to the first times x minus 1 squared times x plus 2 to the first, which is equal to this. And you multiply them, which is equal to this. Now, normally we would use the LCD to add or subtract these. What would have to happen is you would have to manipulate the fractions so that the denominators are the same. Again, it's just like, you'll see that it's just like with rational numbers. Essentially what you do is you multiply top and bottom by the missing factors. You know, whatever is missing, so that so that the denominators are the same. Okay, that's one example. That was so much fun. Let's do another. Here's an LCD as well. Well, here we're going to find the LCD, excuse me. Now, the second denominator is factored already, as you can see, right? No, it's already factored. You have x minus 1 to a power, but that's okay. In other words, you can have irreducible factors raised to exponents, but that's going to happen. Now, the first one, this is not factored. Okay, so let's try and factor it. Well, right away, you should be able to see that x squared we can factor out. Mostly because x squared is the smallest power of x there. So we have x squared taken out. Okay. Now, how do we get what's left over? Dividing. Like so. Dividing. Okay. Just like we saw earlier, you have to divide to see what's left over. And we get here, so we get x squared plus 3x minus 4. Okay, now can this be factored further? Well, it turns out it can. And why is that? Well, for x squared plus 3x minus 4, we want two numbers whose product is minus 4, constant term, and the sum is 3. And the sum is 3. Okay, what two numbers are going to do that? Their product is minus 4, the sum is 3. How about 4 and negative 1? So 4 and negative 1. So we do x plus 4, x minus 1. This product here is what we get. Okay, that's cool. So if we plug it back in here, we get the first denominator factored is this. Now once it's, okay, so it's factored now. We put that down here, okay? Now the denominators are factored. Wonderful. So now to get the LCD, just like before, what do? We do this. We list each irreducible factor, each distinct one ones. I'm listing it in a table like this just to make it easier for everyone. So we have x plus 4, well, that's over here, x minus 1. Okay, these three are, okay, so we have x already, x minus 1's listed already, x plus 6 we list, x plus 4 is already listed. But what are the biggest exponents? X squared, right? As opposed to just x. X plus 4, see? Well, the biggest exponent's 5, so that goes here. X minus 1, we have 1. Right? The exponent's not listed, it's understood to be 1. 3 goes here. And x plus 6, it's only listed once. Its power is 1. You don't have x plus 6 over here. So we take 1 as the exponent. So what's the LCD? Well, it's x squared, x minus 1 cubed, x plus 4 to the 5th, x plus 6 to the 1st, and you multiply. And that is our LCD. That's our LCD. Are there any questions about that? Right, I was going to have you guys try this. Unfortunately, we have like a minute left. But maybe we can just do the first. Let's do the first one together. We'll just do the first one together. The first one, we have 5x plus 9 over this. We have x plus 5 over x squared minus 9. Okay. So here is what we have. Well, again, we just basically have to factor the denominators first. Now, if you do factor x squared plus minus x minus 6, basically you'll just get this, right? You get x minus 3 times x plus 2. You want two numbers whose product is negative. You know what? Let's see. I don't want to rush through this because we have we have about 5 seconds left. So I figured what we'll do then is we'll start from here, and I'll let you guys try these 3 next time. I don't want to rush through it though, so we'll stop here then, okay? All right. Any questions on that? All right, so I'll see you guys next